Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for finding the length of last word in a string. Let's look at the problem description. We are given an input string which consists of one or more number of words and spaces in it. So we have to return the length of the last word in that string. A word is a maximal substring consisting of non-space characters only. Let's take a look at this example in hello world. So the last word is world. So which is of length 5, and here the last word is moon, and also it has white spaces, so we have to ignore that. So the length of the last word is 4, and here the length of the last word joy boy is 6. So the length of the string is ranging from 1 to 10,000, and it contains only English letters and spaces, and there will be at least one word in the input string. Let's look at the approach to solve this problem. So we are given the input, the string the moon, and the expected output is 4 because the last word is moon. The length of moon is 4. So we can use the pattern matching in a single pass approach. Okay, we scan the entire string starting from the first character, and each time we keep track of the current character and the previous character we see. Okay, so based on those two characters value, we can determine whether we have seen the end of the word or not. We can take action accordingly. Okay, so whenever we see a character, we increment the letter count. Okay, so whenever we see a space, we check whether the previously seen character is not a space. That means we hit the end of the word. So far whatever the letter count is the length of the word. So the current letter count will give the length of the most recent word we have seen. Then that letter count will be assigned to the word length. Okay, and then we reset the letter count to 0. We update the word length only if the previous character is not space. For example, in this case, when we are in this position, if the previous character is also a space, that means we are not seeing the end of the word. So we do not have to update the word length in that case. Okay, so that's why we use the previous character to check whether to update the word length or not. Okay, so that's what I'm saying here. Each iteration, if the current character is space, and then if the previous character is not space, then assign the letter count to the word length variable. Regardless of the previous character or space or not, reset the letter count to 0. And whenever we see a letter, increment the letter count. So at the end of scanning, we will have the most recent words length in the word length variable. Let's look at the flowchart. Input for this procedure is a string input. First we initialize the word length letter count variable and then the previous character variable. Okay, so the word length and letter count will be initialized to 0 and the previous will be initialized with a space. Then we enter the for loop which scan the entire input string. So we check whether we processed all the characters. If so, then we go out of the loop. Otherwise we check whether the current character we are seeing is a space. If so, we check whether the previous character is also a space. If the previous character is not space, that means we are hitting the end of word. So we assign the current letter count to the word length variable. Otherwise, we simply reset the letter count to 0. Okay. If we see a letter, if the current character is not space, then we increment the letter count. and then we increment the read pointer, and we keep reading the rest of the characters until we reach the end of the string. So once we process all the characters in the string, we come out of the loop and we check whether its letter count is greater than 0. If so, assign that to the word length. So this is an edge case. For example, if the string ends with a word, then at the we do not have a chance to hit this condition, because this condition will assign the letter count to word length only if there is a space. But if the end of the string do not have any space, but it ends with the word, we have to capture that. So that's what this check is doing. Okay. So then finally we return the word length. Let's move on to coding. First I initialize the last word length and the letter count variable to 0, and then I declare the previous character variable. Then in the for loop, I scan the entire input string. So in each iteration, the current character point to the character we are seeing in that iteration. And first we check whether that current character is space. If so, we check whether the previous character is not space. That means we are seeing the end of the word. So in that case, we have to update the last word length with the value of the length of the most recent word we see. So that is present in the letter count variable. And then I reset the letter count to 0. If the current character is not space, then the letter count will be incremented. After that, I assign the current character to previous character, so that we always remember the character seen in the previous iteration. Once we come out of the loop, I check whether the letter count is greater than 0. If so, assign that to the last word length. So this is an edge case wherein the input string has a word which is exactly present in the end of the string. So to capture that, I do that check, and finally I return the last word length. Next I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool. This program is accepted. Next I'm going to do the code walkthrough with sample input. Okay, we are given this input string and the expected output is 4, because the last word is moon, which is of length 4. Okay. So we initialize the last word length to 0 and the letter count to 0. The previous char is also initialized with 0 value of run. Okay, so that's what we are seeing here, and the current character points to the first letter in the input string. So this loop will scan the entire input string. So first we check whether the current character is space. It's not, so we increment the letter count. So when we are entering, the letter count is 0. At the end of the iteration 0, the letter count become 1. And then we update the previous character. We assign that current character to the previous character, so that then in the next iteration we can refer this variable to determine whether we hit the end of the word or not. Okay. So in the iteration 1, the current character points to H. So we increment the letter count, so it becomes 2. And in the iteration 2, we are hit, the current character points to E, so the letter count is increased from 2 to E, and the previous character is set with E. And the iteration 3, the current character is space, so we are hitting this condition, and we check whether the previous character is not space. Yes, that is true. The previous character is E. That means we just pass the word. So that means the letter count contains the length of the most recently seen word. So here in this case 3, so that is true. THE, the length is 3. So we assign that value to the word length. And then we reset the word letter count to 0 to capture the next word's size. Okay. And the previous character is assigned with the space. In the iteration 4, the current character is pointing to M. So it is not space, so we increment the letter count to 1. So the letter count becomes 1 at the end of iteration 4. At the end of iteration 5, we are pointing to letter O, so the letter count is increased to 2. And in the iteration 6, we see the second O, then the letter count is increased to 3. Then in the iteration 7, we are seeing the letter N, so the letter count is incremented, now it is 4, and the previous character is set with N. On the iteration 8, we are seeing the space, so we are hitting this condition, and we check whether the previous character is not space. In this case it is true, the previous character is N. So we assign the last word length as 4. The current letter count is assigned to the word length, and then we reset the letter count to 0. So that's what we are seeing here. And the previous character is assigned with whatever the current character is, so the space. And in the iteration 9, we are seeing the second space. The current character is pointing to the space. And we are checking whether the previous character is not space, but in this case it is false because the previous character is a space character. So we are not updating the last word length in this case, because only whenever we see the end of the word, only in those situations we update the word length. In our other cases we will not. And then we just simply reset the letter count whenever we see a space. Okay, and then finally we reach the end of the string, and we return the last word length, that is 4. That is the expected output. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the complexity analysis for this input. So we are given the input string, the moon. This input string's length is 10. So in order to find the length of the last word in the input string, we have to scan the entire input array. So we have to perform 10 iterations in this loop. Okay, so if there are n characters, then we have to perform n iterations. So the complexity of this time complexity for this procedure is order of n. And space complexity is, we are not allocating any additional space for this processing. We just use few variables. It is not related to the input size. So the space complexity is order of 1. Thanks for watching this video. Have a great day.